Before we start with this question, there are a couple of things that you must understand and remember. So the first one, you need to understand this diagram over here, right? You need to understand this diagram. So obviously we have 0 over here, and here that would be 90. So if because we know the Cartesian plane, so if we move from 0 to here, that would be 90, okay? And then if you move from here to there, that would be 180 degrees, and that would be 270 degrees. And then if you go back to where you started, that would be 360 degrees. That's the first thing, okay?
Yeah.
So you need to understand that the first quadrant, we're going to represent it as theta. Now let me define theta, all right? Because this theta thing, it's confused a lot of people. So theta is actually the angle that is greater than 0, but less than 90 degrees. So basically, theta is that angle that is found on the first quadrant, okay? And then,
Yeah.
so you'll notice that we will keep using this theta. Why we are keep using that theta is because we know that if we are using that theta, there's a high chance that whatever angle that you are talking about will belong on that quadrant that you are talking about, because theta we know that is actually less than 90, okay?
Yeah.
Because if we can use the angle that is above 90, there's high chance that we can move from that quadrant maybe to another quadrant. Does that make sense?
Yeah. Yes, sir.
Okay. So which means on the second quadrant, we represent all the cofunction as 180 minus theta. So think about it. If I have any angle that is less than 90, then I subtract that angle to 180 degrees, you'll realize that angle will actually be greater than 90 but less than 180 degrees, which would make that angle to belong on the second quadrant. Okay. And
Yeah.
then if
Okay.
you talk about the third quadrant, we will represent all the cofunction or trig function as 180 plus theta. All right. So because if I move from that to that, that is 180 degrees. As soon as I add any angle that is actually greater than 0 but less than 90, I will simply fall under the third quadrant. Does that make sense? So think about it.
Yes.
If I add any angle that is less than 90, the angle will always, that angle that you're going to find there will always be less than 270. But automatically that angle will be greater than 180 because I just added a certain angle on 180 degrees. Make sense?
Yeah. Yeah.
Right. So now I know that that is 180. And then in the fourth quadrant is 360 minus theta. It's the same explanation. Okay. Now, let me talk about general solution now. Why this is useful when it comes to general solution. Now, let's start with the one that is given here because you said you wanted me to explain and you want me to find the general solution of these two scenarios, which is sine
Yes,
theta
sir.
and tan d, and sine c and tan d. Okay, so let's talk about sine first. So we have sine d equal to 12 over 13, right? And then we want to find the general solution for this situation. Now, how do we go about doing this? The first thing that you must look at this ratio that is given here. So you need to ask
Yes, sir.
yourself, is this ratio positive or negative? So you can see that the ratio is positive, right? So
Yeah.
automatically you can see that the angle that you're going to obtain there is the positive angle. So basically you need to look at the quadrant at which sign is positive. So sine is positive on the first quadrant and it's also positive on the second quadrant. Okay? So which
Yes,
means the
sir.
general solution that you're going to talk about is the general solution that is going to talk about the first quadrant and the second quadrant. But if that ratio, the ratio that is here, if this ratio was negative, it was going to be a different story. Because that means we're going to consider this quadrant and that quadrant over there. Because that is where sine is negative. Does that make sense?
Oh, yeah. Okay.
All right. So now the first thing that I like to call this angle a reference angle, right? But it's actually theta. The angle that we're going to calculate here is this angle theta. Okay.
Yeah.
So let's find this angle theta. So you simply say sine theta equal to 12 over 13, and then theta is equal to up sine of 12 over 13. So what is the angle?
1,38.
67,38 degrees. Now look at this. But before we do this, I need to explain this, right? The period of sine is 360 degrees, right? And the period of cos is also 360 degrees. But the period of tan is the only one that is quite different. The period of tan is 180 degrees. Why that is the case is because tan has got the asymptotes at 270 and 90, at 90 and 270, if I'm not mistaken. So that make that trig function to be quite restricted, right? You understand?
Yeah.
Yes.
Yes.
Now, obviously, we got theta, which is actually, I also like to call this angle a reference angle. Now, let's talk about the general solution. Now, the general solution, we're actually going to use whatever sign that we have here. So, which means D, general solution for D will be theta plus K 360, which means it should be 67.38 plus K 360 degrees, where K is the element of real numbers. So that's the first general solution. And then the second one, D will be equal to 180 minus 67.38 plus K 360 degrees, right? There's no need for you to write this twice, right? You can write it once, but let me just write it for the sake of writing it. But once you write it once, most of the time they mark this once, right? They mark this once. So I think when you write it once, it will be okay. All right. Then what is 180 minus 67.38?
112.
112.62, right?
Yeah.
Plus K 360 degrees. Now the question is, as I said, what was going to be, okay, we are done, by the way. These are the general solution for this situation. But now, in the case where you have, let's say maybe that was negative here, okay? Now, what was going to be your general solution? So obviously you're going to find theta and make sure that you use the positive ratio always, right? But keep in mind that the ratio that is here, is this the ratio negative or positive? But when you find this theta, make sure that theta is always positive, right? Because you know for
So,
the fact that, okay, the ratio was negative, so I know which quadrant that I'm going to use, because look at negative as the director that is directing you which quadrant you're going to use. Okay,
oh, okay.
right.
Okay. Yeah.
And then from here, what do you do? Let's say you have as I said, let's say you have a negative ratio here. So the general solution here was going to be angle D is equal to 180, because you know sine is positive on the third quadrant and the fourth quadrant. So it was going to be 180 plus 67.38 plus K 360 degrees. As I said, K is the element of real numbers. So what is 180 plus 67.38?
47,38.
247.38 plus
Yeah.
K 360. That's the first one, right? And the second one was going to be 360 minus 67.38 plus K 360. What is that?
292,62.
292,62 plus K
Yeah.
360. So you can see
So
this.
this is where if my theta for sine was negative, this is what I
Yes.
would do.
Yes, if your ratio here was negative, that's what you're going to do, right? This
Okay.
was going to be your general solution. But
Yeah.
in this case, this is your general solution. This is the correct one, by the way. But this one is applicable only when, let's say, you have a negative ratio on sine.
Yeah.
Okay?
Oh, yeah.
Any question here?
No questions.
Right.
So that means for the question where it says sine C minus D, then I take C, subtract it with D, and then from there I use the general solution
Yes.
on whatever number I get, if it's positive or negative.
Yes.
Oh, okay.
Right. Now let's look. All right. So now let's look at tan. Right. Let's look at tan beta. Let's say now we have tan beta, and then How do you find the general solution if you have a negative ratio? And how do you find the general solution if you have a positive ratio? Like we did before, the first thing that you're going to do, you're going to find theta. Okay, we're going to find theta. So which means if we have a tan, like for example here we have tan angle beta equal to negative 4/3. So we're going to find tan theta, assuming that this ratio is positive. And keep in mind that the ratio is actually positive. So theta would be up to tan of 4/3. So what is that?
The negative 4/3, sir.
No, don't use negative.
Oh, okay. 53,13.
53,13 degrees. Now, what do you do at this point? Now, as I said tan is only have the period of 180 degrees. So which means tan is only from the first quadrant to the second quadrant. That's all. All right. And then on the first quadrant, we represent angles of theta, and here we represent angles of 180 degrees, 180 minus theta. On the first quadrant, that is where your ratio of tan is positive. Then you can use theta. And then on the second quadrant, that is where the ratio of your tan is negative. Then you can use 180 minus theta. Now, at this case, you can see that the ratio is negative. So the general solution at this case will be D equal to 180 minus 53,1 plus K 180. Be careful with this. Plus K 180, and K is the element of real numbers. So what is 180 minus 53,13?
126,87.
That's it, right? So this is true if your ratio is negative. Now, if the ratio is positive, you're simply going to say D, general solution is D equal to 53,13 plus K, 180 degrees, and K is the element of real numbers. All right?
Okay.
Any question here? The question that is given here is quite different because basically here they don't want you to use a calculator, and they're saying here sine C is equal to 12/13, and then they told you that angle C is actually less than 90 but greater than 0, which means it's found on the first quadrant. And because you must be very careful with this question, with this type of question. So actually you're going to construct like a sort of a Cartesian plane, right? And we know that because the ratio is positive, and we know that sine is positive on the first quadrant and the second quadrant. Now, before we read this statement, and when we started to read this statement over here, we have two options because we know that the ratio is positive. Then the first thing that we know is that it's either our graph would be here or here, because that is where sine is positive. Sine is positive on the first quadrant and the second quadrant. Okay?
Yeah.
Now the concluder is this, right? So that statement is the one that is going to help us to conclude which quadrant we are actually going to use. Okay?
Yeah.
Now,
yes,
since they told us that the angle is less than 90 and the angle and greater than 0, for sure that's the first quadrant. So that's the first quadrant. So we're going to formulate like a sort of a right angle triangle over there, and that will be that. That will be 90 over here. And we know that sine theta is equal to opposite side over hypotenuse. And at this case, the opposite side is 12, the hypotenuse side is 13. All right? So, and then angle C would be here, that is angle C. And this would be opposite side, which would be 12, and the hypotenuse side would be 13 over here. And to find the side, we're going to use the Pythagoras theorem. All right? So where we're going to say r squared equal to x squared plus y squared. And then r squared is 13, so that would be 13 squared equal to x squared, that what I'm actually looking for, plus 12 squared. Now that would be same as 13 squared minus 12 squared equal to x squared. So what is 13 squared minus 12 squared?
That's 25. So
That is 25 equal to x squared. Then we are going to square on both sides. So x would be equal to plus or minus 5. Now, obviously, we need to pick the right one. We need to pick which value of x we're going to use. Now, the determiner for that will be the quadrant. Which quadrant are you talking about? You're talking about the first quadrant, and the x-axis are positive on the first quadrant. So therefore, the correct value is x equal to 5.
Yeah.
And x is not equal to negative 5. Okay, so here that will be 5 over there. Make sense?
Okay. Yes.
Then after that, we're going to formulate another one. All right, so and the next thing that we're going to do here, we are going to do the same thing here, right? We're going to draw the diagram, and we know that, okay, the ratio is negative, so we know that tan is negative on the second quadrant and the fourth quadrant. All right.
Yeah.
All right. So we have those two options for now. All right. Is the second quadrant and the fourth quadrant now, and then this would be the determiner. So they told us that the angle D is less than 360 but greater than 270. So obviously that is this quadrant over here.
Yeah.
Understand? So now we can quickly do that. We can formulate. Okay. And you must always draw the line that is perpendicular to the x-axis. Then now that would be from there to there, that would be D, right? And then what do you do at this point? We need to, what is this? We need to, okay, let's talk about this ratio over here. Now, we know that tan is opposite over adjacent, right? It's opposite side. Tan theta is opposite side over adjacent side.
Yes, right?
So which means this is your opposite side, which is this side, which is 4, and an adjacent side, which is that, which is 3. Now the trick is this. This would be negative. This would be negative 4, not positive 4, right? Why? Is because I'm on the negative side of the y-axis.
Yeah.
All right. And I'm going to find this side, which is the hypotenuse, using the Pythagoras theorem. So that would be r squared equal to x squared plus y squared, and that will be 3 squared plus 4 minus 4 squared, which would be 9 plus 16. What is 9 plus 16?
9 plus 16 is 25, so
25.
that means r is 5 again.
Then we come to get r plus or minus 5, but the correct one will be a positive one because this is the distance, right? This is a distance. So therefore r will be equal to positive 5, and r is not equal to negative 5. So that will be 5 here. Okay? Any question here? Okay. So what you need to know is that if you have a sine, right? If you have sine A plus B, so that will be equal to sine A cos B, right? Plus sine B cos A. Understand? And if you have sine A minus B, right? So that would be same as sine A cos B, right? Minus sine B cos A. Understand? So these two are very important. So are the one that we are going to use here. I don't know. I'm not going to talk about the one which is cos A plus B and cos A minus B. There's also the compound angles based on that. But I wanted to talk about this. So in this case, we have sine C minus D. So we're actually going to use this one. Okay, which means we know that for the fact that sine C minus D, right? So that will be sine C cos D minus cos C sine D. You get it?
Yes,
Okay,
sir.
let me just write it here because let me just rewrite that here. So that would be sine C minus D is equal to sine C cos D minus cos C sine D. All right. Now, someone can say, okay, now how this can help me? Now, sine C, we can just come to this diagram. Sine C is opposite over hypotenuse. So we can replace this as as 12 over 13. Okay?
Yeah.
And then cos D is, because cos is adjacent of hypotenuse, right? So cos D is adjacent, which is that's the adjacent side, hypotenuse. So it's in fact 3 over 5. So that is multiplied 3 over 5 minus. Then sine C, cos C is adjacent over hypotenuse again, which would be another 5 over 13. All right, so that would be 5 over 13 times, and then sine D will be opposite of hypotenuse, which would be here, that would be opposite, that would be negative, in fact, negative 4 over 5.
Hmm.
All right?
No,
Then could you
okay.
quickly
Yeah.
multiply this? Quickly multiply this.
Yes, sir.
All right, so you multiplied everything.
Yes, sir.
56 over
65.
56 over 65. 56
Yes, sir.
over 65. That's it. Any
Oh,
question?
okay.
Any question here?
No question.